Okay, we are live. So, hello everybody. Welcome to the OWASP Vienna virtual chapter meeting. We today will have a presentation from Daniel Cuthbert, and the title is "Do You Even Pen Test, Bro?" So Daniel is involved in the work with the OWASP application security verification standard, and that's part, I believe, part of the talk that he's going to be delivering to us today. So without further delay, I'm going to give Daniel the floor. So thanks for being available, and we are happy to hear from you.
I'm honored to be here. Thank you very much. So you're probably all wondering why I have a picture in Russian and what the hell this talk is about. Well, there's actually a story behind this. Mid-2000s, I took a break and left the computer security hacking scene and went back to art. My background has been art and creative, and I used to be a documentary photographer. And I decided to go to Chernobyl for the 30th anniversary, and it was before it was open to tourists, so it was quite an endeavor to get to Kiev, find somebody who could get me into Pripyat, which was still quite heavily guarded and controlled for obvious reasons. But I didn't think about it much. That was in 2006 until the other month when the series Chernobyl came out on HBO, and I hadn't thought about what I'd gone through and the story. And also, it was quite weird because of a lot of it kind of relates to the Appsec world. I've been involved in AppSec for a very long time, since the start of OWASP. For my sins, Mark Curfey and I did the first testing guide. That was 2003. And now I co-lead the Application Security Verification Standard, or ASVS. It's a bit of a mouthful, with Andrew, Josh, and Jim. But the Chernobyl story is quite attached to me because I went there and I got to experience it, and the same goes for AppSec. So there's kind of a story in this talk. So I'm not completely mad. Please don't think so. But what was interesting about Chernobyl was that the message itself was, why worry about something that isn't going to happen? And for me, that summed up the AppSec problems that we had from the last century. So in the 90s, I worked through the normal first .com boom, and it was fantastic. It was, you were doing a lot of network level exploitation, finding bugs. And then this thing called the World Wide Web came out, and it was like, wow, this is quite cool. You can have this web server and you can serve content and people can look at it. And we helped build the Financial Times, FT.com website and backend infrastructure. And for me, it was phenomenal because before that, I was doing a lot of network-based stuff. I helped build a big chunk of European internet through PSINet. And all of a sudden, I didn't need all the hardcore networking level protocols. I could use a browser to hack. And it was interesting because we were testing this brand new web application. And the backend was Oracle, this new fancy database that was unbreakable. And throwing lots of garbage at it, you could get ORA errors back. And I went to Pete and said, Pete, who was the head DBA at the time, this doesn't seem right. He goes, don't worry, we'll stop the error messages getting to the user, right? Seriously, what are you worrying about? Nothing bad's gonna happen about that. That was beginning of 1998. As many of you probably aware, Rainforest Puppy came out with the now groundbreaking research to which we are still suffering from when it comes to SQL injection. SQL injection is now 21 plus years old. It's old enough to drink beer in Vegas, but we still suffer with it. And that kind of sums up a lot of the things. We haven't learned from the lessons of the past. Chernobyl for me is still horrifyingly relevant. Lessons have not been learned. So here's how stupid I was when I was younger. That is the infamous reactor with the lid blue. That was probably about 25, 30 meters away from it. I did have a Geiger counter. I was warned by my guide for the National Nuclear Organization not to hang around certain areas. One of the ones was the reactor. The Geiger counter was going through the roof. But I was young, stupid, and I thought, why not? It's a good picture. But again, looking back now, I should have really listened to the advice. So my background's kind of been very creative, very fashion driven, but also quite technical. And it's weird how those two hobbies are now joining in. And here's a great quote I love from Larry Ellison. The computer industry is the only industry that is more fashion driven than women's fashion. Maybe I'm an idiot, but I have no idea what anyone is talking about. What is it? It's complete gibberish. It's insane. When is this idiocy going to stop? And this quote has stuck with me for a very long time because it's actually quite true. You know, if you look at every single year, there's a new product that comes out. There's always some kind of new tool, new magic bullet, new something that will make your life amazingly good. It will fix your application security woes. It will fix all the O-Day attacks. There's no more zero-day this. Oh my God, it's amazing. It uses advanced machine learning to do AI. The problem is a lot of these products don't fix the basic issues. And I think a lot of that is because basic stuff isn't sexy. You know, if you look at any of the breaches that happen today, nobody admits, yeah, it was quite lame. We didn't harden the box and we got popped and man, it was bad. It's always super sophisticated, advanced nation state attackers. Like, no, it wasn't that fancy, right? We are forgetting a lot of the basics. But I wanted to give like a bit of a sort of like a gentle walk down memory lane to understand how and what we've been trying to do and how we need to kind of move back to that. So this was the first OWASP web application, 2002, I think late 2002, Mark put this up. You can tell that by the phenomenal use of tables and boxes and great fonts. Luckily, we didn't have any of the construction icons, if anybody can remember those GIFs, you know, old man digging type stuff. But this kind of laid out the mission at the time. Now, bear in mind, this was the turn of the century, and that does make me sound old. But this new thing called World Wide Web was out, and web applications were now being built. And we had things like XML data exchange, and it was all very well and cool and exciting. The problem was we had no idea how to test this stuff. And that's where Mark and I started with the testing guide. Like, all right, so you have this thing called a web application, and it makes use of this thing called a web server called Apache, which was on 0.8 or 0.9. And it makes use of a backend database of some sorts and some kind of web language. Like, what do you do? So the testing guide kind of was born, and it was great because there was nothing out there before. We were literally writing the book, and it was a great way to learn how stuff was built. At the time, Mark was quite visionary. We didn't know how big this was get. And there was, 7 people at the start. It was very, very small. At the same time, Bill Gates came about with the now legendary trustworthy computing message. And if you've never seen this message, I urge you to look for a copy of it on the internet. It's phenomenal because prior to that, Microsoft didn't really take security seriously. And you could see that by a lot of the products that came out. Because, you know, IIS was a joke. Windows was a joke. You know, anything that Microsoft kicked out was really, really badly written. And mostly because security wasn't an important feature. It was all about features. It was always about what the product could do rather than secure stuff. And Bill kind of stood backwards and thought, you know what, this is crazy, right? We've got loads of worms coming up. We've got more and more bugs coming out. We've got, you know, Microsoft products being broken into left, right, center. We need to stop and rethink of this. And what Microsoft did was, this was the start of the whole shifting left, or as we've called it back then, SDLC, the Secure Development Lifecycle, whereby Microsoft stopped all dev and they looked at what they were building and they thought about how they could make this a lot more secure. And it was a really important part because if you look at the 2 dates, OWASP 2002, Bill Gates 2002, that was 18 years ago, right? So for all the fancy shifting left stuff, we've been trying to do this for a very, very long time. The problem is we've not really taken it that seriously. You know, 18 years on, we still have some really terrible bugs that appear, and more so in the last 18 months than for a very long time. You know, if you look at some of the major bugs that have been found, like it's embarrassing. It's like people never thought about what was going on before then. And to give an example, this was 20th of May, so 7 days ago. So Cisco, a very big company who should know better, our normal favorite friend, Java, a vulnerability in the Java remote management interface of Cisco Unified Contact Center Express could allow an unauthenticated remote attacker to execute arbitrary code on an affected device. Now, if you didn't know the date of this, you probably could have thought, oh, it's probably a couple of years old, but it's not. It is May 20th, 2020. What's scary about this is that we know that Java, and indeed a lot of application languages out there, have a problem with deserialization, right? We also know that input validation has been the bane of our lives for a very, very long time, going back to RFP's SQL injection in 98. The problem is, even the big players, the ones with mega budget, the ones that have teams of AppSec professionals, massive amounts of people who should know better, still struggle with the ability to stop an attacker sending a malicious serialized Java object to a specific list on an affected system that gets them code execution. Now, this particular piece of software, if you've never come across it, is mostly used by call centers that often deal with banks and other financial industries, call centers that have a lot of personal data, call centers that could be made to do other stuff. So this kind of bug in 2020 is shocking. You think, what seriously has happened? And this got me thinking, like, what actually has gone wrong? Because it's not like we don't have enough documents out there anymore. It's not like we don't have enough SAST and DAST and amazing tools that come out every year that will scan all your code and use machine learning and so on. So why is it that you can still get zero interaction RCE running as root on a device in 2020? And this is when I start to turn to people and look at who made the web and see what they think. And what was interesting about Sir Tim, who I have immense respect for, and I think Tim Berners-Lee is just a phenomenal visionary from what he built. And in 22nd of March, 2018, he came with a quote that again has stuck with me. And this was to do with Facebook and what Facebook was doing. And he said, "This is a serious moment for the web's future, but I want us to remain hopeful. The problems we see today are bugs in the system. Bugs can cause damage, but bugs are created by people and can be fixed by people." And it's quite a bold statement, right? Because if you think about it, the web came about as an idea in 91. Now, I started earning a wage for hacking as such. It was never called that back in the time in 1996. And it took until the 22nd of March, 2018 for the developer, the visionary of the World Wide Web to finally say, damn, we've got a bit of a problem. And he almost went into a thing where he says, I can imagine Zuckerberg is devastated that his creation has been abused and misused. And he says there, some days I have the same feeling. And it must be quite hard for him, who has had such a profound impact on the lives of billions of people, which the web has, to look at how it's been abused and how easy it is to hack people now and to gain access to private data and do really miserable stuff, sway elections, change countries, do all that kind of stuff. There must be a very horrible feeling in your stomach to know, like, wow, am I responsible for this? Did I not make it secure? Could I have done something more? And then that took me on a journey into our industry itself. Right at the start, when we were writing the testing guide, there wasn't that much information out there. There really wasn't. It reminds me of a story my old man used to tell me of him growing up, where it was really hard, had to walk to school backwards, naked, barefoot through snow and all that hardship. It kind of was like that at the start because we didn't have the amazing wealth of information we have today. I love YouTube. I don't stop learning all the time. I'm a curious child, and YouTube has given me so much because if I have a question or a niggly thing, I go to YouTube. I learn so much. And, if you think about our industry today, we have it where we have so many TV shows about hacking. Some of them are really bad, but some of them are really damn cool. This one, for example, like, great depiction of what our industry is. It makes it look glamorous. Everybody wants to be a rock star hacker. Everybody wants to pwn stuff. Everybody wants to go to Black Hat, DEF CON and break into shit and all that kind of stuff. The problem is those people who do the offensive side are often seen as cool. The people doing the defensive stuff, they're the ones that are not glorified as much as they should be. And I think that's, for me, is the problem. Now, why do I say that? So let's look at all the tools that we've got out there. We've got amazing frameworks, we've got amazing documents, we've got more books on how to code security, how to build stuff, how to pen test. We've got pen testing distros coming through our ears. We have YouTube channels, we've got rock stars, we've got bounty heroes, we've got everything. Surely that means the web's more secure. Okay, so these are the amazing TrustWave stats that come out every year. And what I like about these stats is that they give a good understanding of kind of a state of the nation as to where we're at. And for me, they're always a good litmus test to say, like, are we getting better, or are we getting worse, or is it a bit more positive, or man, do we have to go back to the drawing board? And every time I look at them, I start to get a bit sad because I don't think we're getting better. Now, from the subject of data compromise, the interesting factor is how long does it take the company who potentially have lost data to understand that they've been pwned and data's been lost? And at the moment, TrustWave found that that was 11 days between intrusion and detection for internally detected incidents. Now, as somebody who built a career in breaking into a lot of things and stealing a lot of data, 11 days is a hell of a long time, because that means an attacker isn't worried about getting caught. They can take their time, they can figure out the most valuable stuff, and they can go from there. Now, all right, let's look at the external stuff. We are getting better there. In 2017, it took 83 days between the intrusion happening and somebody actually noticing something bad was, going down. 2018, we got better. I don't know the numbers for 2019 yet. But if you look at the industries most affected, it makes sense because most attackers are going after stuff that's valuable. And that's either retail or financial, or indeed stuff that they can sell, right? The most common stuff is card data and so on. But how are these attacks getting in? Well, the most common factor, and it's probably of no surprise to anybody here who does any kind of offensive stuff or tries to stop hackers, is that email. Email is a phenomenal conduit for getting into an organization because we've still not been able to build a system where somebody can click on an email, which they're supposed to do, or click on a link, which they're supposed to do, or an open document, which they're supposed to do, and have that, whatever they're doing, not do something bad. And I think that's a failure to what we are as an industry rather than the user. And, it was very commonplace back in the day to blame the user, stupid user clicking on stuff. No, that's what we asked them to do. That's what we do ourselves. If we can't build stuff that's secure, then the blame has to be on us. Now, things are getting better. 2008, the dark days, wow, 87%. It was easy. Just send a really badly worded phishing thing. You're in like Flynn. It got better in 2017. It kind of went bad again in 2018, right? And that's probably because more and more people are now using the web. They're using a vast majority of applications with passwords and different consoles and so on. And it's very, very hard because that's practically where our lives are today. And then the same thing goes for Word documents. Like, people do send a lot of these documents, and Word, for some baffling reason today, still has a dizzying amount of functions and functionality and operations that allow stuff that most people never use, that are heavily abused. And then we come to web attacks, the stuff why most of you are probably here. Are we getting better at building web applications? Possibly not. All right, because if you look at the attacks that are happening today, just last week, EasyJet, the big aircraft carrier, they were nailed. We're not sure how yet, but they were nailed in October 2019, only really caught in March, probably through a web application flaw. But it seems that attacking web applications is still really, really popular. So this brings me into the Chernobyl story again, right? Currently, we still have a phase where we have a lot of overconfidence. Overconfidence in the amazing tools that we can buy to put in front of stuff to stop these attacks from happening. And that overconfidence comes in from, account managers overselling products. We will stop all 0 days. Just put our WAF in there. You'll be safe from everything. To people not really understanding how this stuff is built. Also, a lot of people aren't sure of what exactly they're looking at. Right? Same thing that went in with Chernobyl, right? Chernobyl, prior to the incident, had trouble-free operations. If we translate that into web application or application security, we've had no known attacks. But if you looked at how Chernobyl was built and the reactors, it was very large. It was loosely coupled, it was over-moderated core, and it was hard to control. I'm sure many of you can relate to a lot of organizations where this is the same thing. The code base has evolved over 15 years. Thousands of people have been involved. There's stuff that nobody knows what they do anymore, but it still happens, right? So you can see why things started to fall down. Also, the reactor itself had a confinement, right? Capable of only protecting a small loss of reactor coolant, right? What they didn't plan for was multiple tube failures, right? Again, when we have a lot of breaches, we don't expect the worst to happen. We expect the hacks to be really small. So how Chernobyl happened, for those who've never been interested in it, early in the morning on the mid-shift in the control room, a group of well-intentioned operators conducted a test to demonstrate the relationship of certain plant parameters, right? Testing and production. The shift supervisor approved the test, although he and the operators did not fully understand the design basis of the systems. I think we can all relate to that. The operators allowed the plant to be operated in an unacceptable region of safety. The test was not evaluated or approved by the safety design group, and the operators felt a sense of urgency to finish the test. Like I said, a lot of the stuff that happened in Chernobyl relates a lot of what I've done in my career. It's Friday afternoon. The application is going live on Monday. You need to do a pen test now. But no, there's no buts. The application is going to be pen tested. Make sure there's no bugs. We're going live on Monday. Or the famous thing that happens is we've accepted the risk. We've almost built this mindset into how we do things today. And that kind of makes me think, like, we've almost lost our way a lot. It's 20 years since the turn of the century. We now have a web that all of us rely on for a vast number of things. And I almost feel we're at the stage now where we need to get back to basics. Now, what do I mean by basics? I did a keynote in the Middle East a couple of years ago, and my dad's a structural engineer, a very traditional old school engineer, and he always takes the piss out of me because he says, you call yourself a computer engineer, but actually you're not. And I was like, this really annoyed me. Like, what do you mean, old man? Like, different world. He was like, well, let me give you an example, right? You've used a lift before. I was like, yeah, I've used a lift. He goes, well, how do you think lifts are built? So when he builds a lift, it's normally for industrial operations. So he designs oil mines, petrochem refineries, arsenic processing plants, like heavy industrial stuff. And he says, like, when we need to ship equipment up through to the heavy levels, we need a lift, right? We don't just decide, we're just going to throw stuff together. There's planning. So I thought, okay, maybe he's onto something here. So I tried to look at stats at how many lift journeys there were in the time I was doing the keynotes, which is actually quite hard because it's not exactly noted. But I found that roughly there are about 18 billion passenger journeys in 2017. That's 18 billion people getting into a box, either hurtling upwards or hurtling downwards at an alarming rate. There were 27 deaths from a lift failing across the globe, which is pretty damn impressive, because that relates to 0.0015% of all journeys. I'd say that was a pretty good security record, right? Considering how valuable and how important and how this thing could kill you if it wasn't designed right. So he said, right, when we design a lift, what we do is somebody comes up with an idea. We need a box that's going to be connected with cables and normally a concrete thing at the bottom, a weight, and it's going to go up and down. And it needs to carry 15 people with equipment. So they start off and everybody sits down and they say, right, we want to build this, this, and this. It's going to have this, and we're going to have this so much budget. And the next thing they go is, right, we need to build it to standards. It has to be safe, it has to be secure, it has to be robust, and it can't kill people. We then work out how much is this going to cost upfront, because it needs to be safe, secure, and robust. Those three things are paramount. You can't decide to not have one of them. That's it, right? If there is no budget to do the three, they don't build the lift. We're not very good at that in security. Then the engineers go about doing that. And again, they build to standards. Like, they make sure that when they build something, they test it. A welder does the welding and somebody comes along and tests that welding and says, that's a good weld, or that weld has air bubbles in, we're not doing it. They test the cables, they rely on standards. They make sure that by the time that lift gets into production, as in the mine or underground, that thing has been tested to death. and it's not done the day before. And generally people don't die, because that's one of the fundamentals that they agree at the part. Like, if you're going to build a lift, putting somebody in a box that's going to hurtle to earth at 100 kilometers an hour is not going to be good if it keeps on breaking, because you can't reboot it. So that leads me into the ASVS. It's quite weird doing a conference like this because I can't see anybody's faces, but I'm assuming some people have heard of the ASVS. The ASVS, or the Application Security Verification Standard, was kind of a turning point for us to say, right, we need to get back to those basics, right? And it's a standard that says, right, if you've got an application or a web service or something online and you want to build it and do testing for it, this will help you. Now, it came about because prior to the ASVS, if you build an application and you go through an SDLC, normally towards the end, you'd have to get it pen tested. Now, this is where the confusion sets in, because what does a pen test mean? And this is coming from somebody who used to be a pen tester. Like, what do I look for? Now, I could use the OWASP testing guide, or indeed, a lot of people test against the OWASP top 10. And I still today have no idea what that means. So we were like, well, if I'm an application owner, I don't know what it actually means to do a proper pen test or a proper application security test. Do you? Like, nobody really did. So the ASVS came out in version 1 with some really good guys, Jeff and co. And it was a great start, but it was very hard to use. And what I've learned over the years is that if you're going to build a standard, it has to have 3 fundamental things. 1, it's got to be really easy to use and read. There is no point having a standard that's hard to read, hard to understand, and hard to implement, because people will just ignore it. 2, you need to have it accessible to all. Now, for version 2 and version 3, we made use of Word to do the editing, and it was horrible. I hated every moment of it because it was not collaborative. You had to save your Word document and put it into GitHub at the time, and oh my God, it was miserable. Now, for version 4, when Andrew and I decided, you know what, we need to do a massive rethink, we said, we're going to make this appeal to the customers, the users of this standard, the developers, the technical architects, the computer engineers, the yous of the world. And we thought, we need to be fully transparent. So let's use GitHub, let's use Markdown, and we will do everything where people can see what we're doing, right? And we want to do this because we want people to feel like they are part of the process. They are owners of the ASVS. And indeed, there were a lot of people who were quite nervous about it at first. But what we saw, which was amazing, and I still talk about today, and I indeed use for my day job, is that people were finally doing pull requests. They were going in and saying, hey, like, you're missing this, or this doesn't make sense anymore, or by the way, there's a spelling mistake here, or actually this makes absolute rubbish, you've not thought about this. And what it meant was the standard no longer became the 4 of us pushing it to a massive community-driven program. And even to this day, we still have people giving us amazing feedback. So we then thought, right, how do we make the ASVS even more open to everybody else? So we thought the ASVS was available in GitHub, and you could pull down a PDF, you could pull down a Word document, you could pull down a spreadsheet. And then I made a CSV version and finally a JSON version. But then I thought, like, a lot of people would probably just want a web application. So for the day job at Santander, Adam and I, who works with me, we decided to build a web application that you can pull down from a Docker image, and you can spin it up wherever you want, be it on-prem or zero trust, wherever you want, and you can have an application where people can use. And basically what that enabled was people who could now turn around and say, right, we're building an application. We want an application that's level 2 compliant. And at the same time, when you do the testing of that application, we want to make sure that you're doing testing of the same stuff. And that's kind of how the application standard kind of grew, right? We wanted it to be a control-based thing where we say, right, we have these 3 levels. Level 1 is the absolute bare minimum that any application or web service or something should have when it comes from a security and usability perspective. Now, the nice thing about level 1 is that it's practically automated. right? So you could pull that into Web Application Scanner or a Dash tool or a Python script or whatever, and have that automatically run all the damn time. And we built it that way so that people could adopt it into their tools. And indeed, I've been pressuring a lot of friends who build a lot of the modern Dast and SAS tools to say, hey, team, please, seriously, put this into the tool. Level 2 is where we feel most applications should sit today, right? Now, level 2 is interesting because what we wanted to do with version 4 was that we wanted to introduce new topics such as threat modeling. Now, threat modeling has been around for a very long time. It's not new at all. But finally, people are starting to realize, hey, this actually helps. At the start of a project, I want to build cheese. I want to sell cheese on a website. Okay, let's go through and actually do a threat model to see what kind of attacks might happen against the cheese website. What do we have to plan for? What should we be worried about? And how should we make sure that whoever's building the application actually does stuff to stop it from happening? So that was what got introduced in version 4, and it became really popular. And at the same time, we also had amazing feedback from people in the community who've taken it one step further. Now, one of the comments a couple of months ago was, well, that's all well and cool, but how do we add this into a good CI/CD pipeline? I was like, well, I guess, yeah, we didn't do that at the time. So basically, a good person came out and said, you know what, I'm actually building this for you. And this became a pull request, where now you can specify this as part of a CI/CD pipeline. And if they don't exist through the checks of either a manual or an automated process, the build fails and people need to go through and fix it. And I thought that's like a phenomenal example of like what happens, right, when the community gets involved. And it's quite simple, right? You can go against all your applications. You can say, right, for level 2, I've got 134 open issues and pull requests. What that means is, wow, we haven't thought about these issues. We want it to be level 2 compliant. We need to fix these before we go live. And this is really, really important. And this goes back into where we, as a security community, need to embrace more people to use our tools. Now, for those who are interested in this, it's available at github.com/spider ASVS, and it will eventually make itself into the master branch. But this is kind of where we're going. And it touches back into an amazing book that I'm sure many of you have read by Gene Kim. It's called The Phoenix Project. Now, what's amazing about the Phoenix Project is that it kind of bridges the gap between developers and those who build and security. Like I said before, security was always you need to do this because of X, or if you don't do this, something's going to happen, or no. Security just says no. And Gene touched upon that in the book, and a lot of people didn't like this, but it was quite relevant because he said that information security is always flashing their badges at people and making urgent demands, regardless of the consequences to the rest of the organization, which is why we don't invite them to many meetings. And this was kind of my aha moment. When you look back at a lot of the demands that security have made over the years, we have been like that. We have come up with absurd ways that attackers might attack us. We have come up with things that say, you know what? No, you can't do this because X, Y, and Z. But the reality is we don't actually take into consideration the business, right? So I think that's where security needs to, again, get back to basics and start working with people to get back into working together as a team, as much as that sounds very cliched, because we have to do it. Sorry, I'm going to get bombarded by a child. Thank you. I'm on a call. Out you go. Shut the door. Thanks. Perils of working from home. Sorry. And that kind of sums up, where we're going. I think what I love about, the various ASVS chapters around OWASP chapters around the world is that we're finally starting to get this massive community now looking at changing the status quo, because part of me is quite sad that in 2020, it is still really easy to break into applications when we have a lot of amazing tools and standards out there. And I know I'm biased with the ASVS, but I do believe, and I've seen the benefits of the ASVS used in organizations where it can make stuff a lot more secure if it's used and people understand how it's working. So for that, thank you very much.
Okay, everybody, do we have questions for Daniel from the audience? We don't have anything in the chat yet, so please enter your questions. So, I don't see any questions in the chat yet, so I'm gonna start. Daniel, what kind of plans do you guys have for the ASVS future? So, you now mentioned this GitHub. You gather a big community. So, what is gonna happen?
A very good question. So version 4 has been out for two years, maybe a little bit more actually. We are now working on the next release. Like I said, one of the things that Andrew and I and Josh and Jim are quite strongly believers of is that you don't make lots of changes to a standard. And when we released version 4, a lot of people told me how they'd embedded it into their workflows and their company processes and so on. And they were concerned that lots of changes could break stuff. And I've taken that to heart. Like, I don't think a standard should be updated every 6 months. It should be stable and useful. And that's why the peer review helps a lot. But that doesn't mean that progress stops. So for version 5, we obviously are trying to make sure that the standard is still relevant. The world of application security and development changes at an amazing pace. One of the things that we did in version 4 was we removed the IoT capability. Now, it was quite a controversial thing because a lot of people were like, well, why are you doing that? And part of the reasoning is that IoT itself and the mobile side are massive subsets of the ASVS. And you didn't want a standard that was going to be grossly vast and complex to use. So we kind of branched out and said, listen, the mobile ASVS, go on, we will reference it. Same thing goes with IoT. And I think that's probably what we're going to do for version 5. Look at the areas that need the help the most. Take input from the community. And I cannot stress this enough. The community is really important because you're the ones that drive the development of the standard. Like, it's your standard. It's just we trying to guide the ship and we have ideas where we're going, but everybody should have ownership in their standard. So if you've got something you'd love to see in version 5, submit a pull request, submit a problem on GitHub and we'll go from there.
Okay, thanks a lot. So we started getting questions from the audience. So we have Sharad asking you to share the GitHub repo again.
It's really easy. It's github.com/OWASP and then ASVS.
We have another person here, Neon Smurfs. Is ASVS becoming not only a tool to evaluate the application, but it seems that it also becoming a process maturity model? Is there a collaboration with the OWASP Open SAM team?
No, not yet. I don't agree it's becoming a process maturity model, not as such. I'd be worried if it was. ASVS has kind of always been there as a technical guide to say, like, here's how an application should be built. These are the things you should look for. And if you're testing applications, these are the things that the application owner expects from you. The stuff that the SAM team's really doing is very important, but I wouldn't say that we're moving into a process maturity tool or model. But there's definitely areas where we want to collaborate. We just haven't done so yet.
Okay, another question here. Is there a method process of determining the ASVS level to apply to an application?
Yes, a very good question. So there's 3 levels. Like I said, level 1 should be absolute bare minimum. There is no argument there. Like, you should do this for every single application, web service, API, whatever you build on the internet. Ideally, for an application today that handles some form of PII data, whatever that is, level 2 is where you should aim for. The one that is the niche and probably the hardest to get to and the most expensive is level 3. And that's generally for applications or services that are incredibly critical. So applications that control power, water, life, financial, tax, that kind of stuff. And if you look at level 3, you'll see how in depth it is, and it's labor intensive. You can't automate a lot of it, but kind of and I know a lot of the tax offices around the world now use level 3 for their applications, and rightly so. It's what me as a citizen would want.
Okay, thank you. We have another question here. Interesting question. Given the stack nature of web apps now, you have platform, language, framework, app code. Does ASVS help identify how to harden against deeper vectors?
Yes, to a degree. Something we're going to look for in version 5. We don't want to go completely deep where we say, right, here's how you do everything in Java, because that would mean that the standard just becomes vast. There's a balance here. But if you've got ideas of how we can make it better, please, by all means, I'm all ears. But yeah, it's definitely something we want to look for in version 5.
Okay, another here, a two-part. That's the opinion that there is a lot of stuff to do to get everybody respective assessment tool sets and get it done, because it's still intimidating for many developers. So is there some focus to make it more available for non-security people?
Yes, 100%. And if you haven't read the version 4, you will see that the language has changed drastically. It was one of the things that I've tried to look for. I didn't want it to be just for security people. I want the language to be less harsh, less, you must do this, you have to do that, can't do this. Very negative words being used, and more receptive and open to everybody else. And there's always room for improvement. That was one of the things that we tried to do with version 4. We have to be more inclusive of everybody. And I'd like to think that version 4 was there. But, again, if you find something you think, man, that just doesn't read right, please help us out.
Okay, thanks. Just a couple more questions. Can you give a brief example of ASVS being included in a CI/CD pipeline?
Yes, I can give some examples that we've built. So, for example, let's say encryption, right? We built a Python checker that when an application is going live, be it Nginx or Apache or the application itself, we can go through and say, right, does the config file of the application make use of these weak ciphers? If so, go and check for them. If it does, the build fails. And that's the nature of what we're trying to do with the ASVS, where you can automate a lot of it in level 1, and you can automate whatever language you want and get that into a pipeline. So we are doing it at the moment, and I'm trying to eat my own dog food, to coin a phrase, and yeah, so far it's working.
Okay. And just to complement this question, another one, do you know a project with example snippets for testing that can be added into unit testing?
I do. I'm going to give you a URL. Let me put it in the chat thing. So we are trying this in, it probably won't let me do a comment, actually. No, it won't. I'll put it into the private chat. Maybe the guys can push it in. So this is called Dr. Header. It's one of the projects that we've released into the community. It's quite a simple piece of code, but basically it checks to see that the headers of a web application are present. And we've added that into a lot of our unit testing as well. So again, baby steps, but we're trying to get there.
Okay, and I'm gonna get one last question. When security is not a focus yet, what is the best approach to get started with ASVS?
Very good question. I think a lot of people still don't see the value of security. And the analogy I like to give now is when you go and buy something, let's give an example of a mobile phone. I expect the mobile phone to not burst into flames when I'm holding it to my ear. I expect the mobile phone to work all the time and do so in a secure manner. I think that now, more than ever, a lot of the consumers in the world now expect some form of security, because we've all become tired of breach. I call it the breach fatigue. Every single week, somebody's getting hacked. Now, when my mother-in-law, who is mid-60s, starts talking about security stuff, that I think we've actually hit the message where people are now going, I want a product, but also want it to be secure. And I think if you're building a product or you're involved in a project and security is still not relevant, I think now's the best time to say, why not? We have GDPR, we have all these controls and frameworks coming in. We've got a more savvy consumer base asking for this. WhatsApp is a perfect example. People know that WhatsApp is secure. They know that they have end-to-end encryption. And I'm not going to get into the debate about end-to-end encryption, but people now kind of assume this is the de facto standard. So it's a lot easier than it used to be, but there's still a lot of people out there who just don't see it as a thing.
Okay, that was the last question we had. I think maybe I missed some, but I apologize for that. So again, I'm gonna thank Daniel very much. It was a great presentation. We got a lot of people watching, and it's if Daniel, if you don't mind, it's gonna still be available on YouTube after for other people later on. And yeah, thank you, and have a good evening, everybody.
Thank you. Cheers all.